Uh, Hello. One of the
Hi.
questions, one of the questions I was wanting to ask you was, how long have you been working on your PhD so far? Like, how many years?
Well, so first, I think we should probably be like, hi, my name is Jill Grest in the Interaction Lab. And who are
Right.
you?
I'm Arnie Matosian. I'm from BCC. I'm in a College 1 class right now. Sorry about that.
All right. Okay. So I've been in the PhD program at the University of Southern California for 4 years. I'm about to start my 5th year. So I'm about 2/3 of the way done with my PhD.
Okay, cool. So, what are some requirements that you've had to accomplish, or you still have to do to get your PhD in this field?
So how a PhD works, at least in computer science, but it's very similar in all of engineering. Usually, so this is USC offers a combined master's and PhD program, so that's why it's 6 years on average. So it's 2 for the master's and 4 for the PhD. You can get your PhD and your master's at 2 different places. I got my master's at USC as a part of my PhD program. So usually, this is because the class requirements for a PhD and for a master's are very similar. And so here at USC, the class requirements for a master's and PhD are almost exactly the same, except for a couple of requirements on the master's side. So for us, it's 2 years worth of classes taking 9 hours a semester. So like two classes a semester for 2 years. So how many is that? Eight classes plus a couple of extra things. So a huge amount of hours. I think it's like 30 hours or something. I don't know. You can always look it up on the website to be sure. I'm sure it's different in different universities, but it's 2 years of coursework about. It took me 3 years to finish that 2 years of coursework because being a PhD also involves doing research while you're attending class.
Right.
So nothing wrong with taking longer. And also, let's see. So the type of coursework, at least here, is very much similar to an undergraduate CS degree, where you kind of take like general classes, like you take a networking class and a database class. And, you know, my work is in artificial intelligence and robotics, but I still had to take a class on operating systems, for example. And depending on which school you go to, a smaller school might have like more customization available. But for us, a lot of it is sort of a more advanced version of undergraduate classes that we took, as well as special classes that are offered less frequently that are more relevant to what we're doing. So also professors will make special classes. There's like a lot of us that are interested in affective computing is a good example here because we have the Institute of Creative Technology. So the professors there make special classes so that all of us grad students can learn about what they're doing.
Oh, okay.
What are the requirements? So you take your classes as a PhD student. That usually takes 2 or 3 years. Here we do a screening in the second year, which is just they look at your grades, they check with your advisor to make sure that you're doing stuff and you're in the program and it's working out. At other universities, they do, we call it a qualifying exam, but it's also called a proposal. Early on in your PhD. For us in our lab, we do it a lot later than a lot of other places, but the general like timeline is that you're screened and then you do your qual or your proposal, which is where my thesis to be. And the format is like, this is what I've done so far, and then this is what I'm going to do from now until my defense. And then at the end you have your defense. So in our lab, year 4 is your qual. So my qualifying exam is in February. And then my defense will then be I'll say that it'll be 2 years after that, but it'll really be 3 years because we were projects. So it's usually that kind of timeline. So that's kind of, every PhD kind of works in the same order, although when you do those steps kind of depends on your field and the lab that you're in and the school that you go to. But everybody has to propose and everybody has to defend.
Okay. You also mentioned you're doing like research and projects along with your coursework. Are you like working on any right now, or is there like any that you have done that you'd want to share?
So for any PhD student, when you start in a lab, they're just going to probably put you on a project to start off with, regardless of where you kind of want to go with your thesis. So the project that I was put on when I first started was looking was the end of a grant, which is actually ending this year, where we were working with social skills therapy for children with autism spectrum disorders. So that's a big thing in our lab, one of the populations we've worked with for a lot of stuff. And so my first project, so I'm interested as part of my thesis work in general I'm interested in adaptive personalized feedback from a robot. So an embedded robot home or your school, and it's going to be a buddy and help you manage your healthcare, and it's going to adapt to what you prefer and to your like current skill level with administering healthcare to yourself, whether that's practicing movements or therapy, or whether that's taking medication at a certain time and understanding what your medication does and all that kind of stuff. So the first project I worked on was graded cueing feedback with children with autism spectrum disorders. And that was for the first, I guess, 3 years or 2.5 years of my PhD. And so it was really like a master's thesis, because now I know what my thesis is going to be. So like really that was like a master's thing. And what we did is we looked at learning and giving the appropriate level of feedback from a system based on observed user ability. So basically you have this constant feedback loop where like I'm seeing how good you are at this task, and then I'm trying to match my feedback to how good you are, and then maybe you get better over time. So I don't want to frustrate you, and I want to keep matching you throughout the entire. And so that's the computer science contribution, and then the social science contribution is to actually bring it to a school. And we worked with a class specifically for autistic students. So there were about 12 kids, elementary age. And they did a copycat game with the robot. So it was like, oh, the now's going to make a pose, and then I want you to copy me. And we use the Kinect sensor for a lot of stuff. So we use the Kinect, just the like Xbox Kinect, to get the kids' pose and compare it with what the robot was doing, and get them to give them feedback based on how well they imitated. And in general, we got some promising results. One of the big things is that you can validate your model a lot with simulated data, and be like, yes, this works, this adapts the way that I want it to. And then you take it to actual people, and you get very different data. You have noisy data. You have unpredictable behavior. You have stuff that maybe you didn't think about when you were doing it in the lab. And so in general, we saw an improvement, but it was too short of a time span for it to be a significant improvement. So we focused on stuff like, well, the kids liked the robot. They always imitated the robot. They knew exactly what we wanted them to do without us having to tell them, which is always a good sign. And that they enjoyed it and that they wanted to keep going. And so if there was something larger that was implemented next time, then that would probably also be successful. So that was the big thing for that. And that's the kind of results you get with human subject research. You get especially special needs human subject research, where you get like, oh, well, this shows promise, but it was just one study, and we need to do more studies in order to know for sure. And so that's what I worked on in the past. Currently, I'm working with Children's Hospital Los Angeles. We're looking at anxiety reduction. So another part of sort of this long-term healthcare picture is reducing anxiety about the healthcare that you have to receive. So we have a robot that's going in to talk to kids who are about to get an IV inserted. So they are about to get an MRI, and they have either a trace that's going in, or maybe they have anesthesia that they need, because it's a long MRI. And so the robot is there to help Child Life Services reduce the child's anxiety about the insertion and about needles, because needles are scary. So it's like a fun buddy that's there to try to get at the kids from like a different angle. And for us, we're interested in, well, okay, can this algorithm adapt to this kid's level of anxiety, and can we give feedback from a robot that's meaningful, that reduces anxiety? What kind of stuff works and what doesn't? And all the while in the background, it's kind of building this picture of all these different pieces that add up to a sort of a personalized healthcare system. And when I'm finally done and I'm going to defend my thesis, then it'll be taking all those pieces, putting them together for one final big study, and then presenting that.
Oh, okay. Wow, that's amazing. That's like That's a lot. I feel like that'd be really helpful. So
It takes
you're mainly, yeah. Are you mainly then focusing on like human-robot interactions in like your research and your projects more of? Like, is it more around that than like the cognitive thinking and everything, or is it tying together? Like,
we're necessarily like at this weird like, so we're computer scientists, but we
mhm.
have to know social science and cognitive modeling and social psychology and all that stuff in order to create these models. So
Okay.
I know you end up knowing, I know a little bit about machine learning and I know a little bit about cognitive modeling, but I don't know a lot about both of those things. So a lot of what
Okay.
we do in the lab is sort of translate social science into something a computer can understand, which is really complicated and difficult, as you can imagine, because you have to take something like, for example, Ross Mead's thesis, he's going to graduate in December. His thesis is on proximity, so proximity mix and social spacing, so which is something that's described by social science, and like in some cases it's actually measured out, thank goodness, but other things, it's not like, oh, you need to blink once every this many seconds in order to appear normal, or oh, you need to be like this, and then when you get into more emotional stuff, like you need to, if someone is this anxious, you need to respond in this way, like, and we need to turn that into numbers. So a lot of that comes from data collection. And some of our stuff, some of the ways we collect data is from social science. So like doing a focus group but social science has really big numbers. So when there's a social science study, it's like a thousand people. When there's a computer science study, having 30 people is like, oh yeah, that's pretty nice. You got 30 people to do this. So on social science, we don't have the power, the statistical power to make any claims. And in computer science, we're doing stuff of like, I just want to see if this robot will respond to this person correctly. So they're like, what's the big deal? You don't even have to move anything. Like you don't have to, you need a robot arm, pick up a block or open a door. What are you doing? So we're very much like at the middle, and kind of like both sides are like, what are you doing? You're not doing what we do, so it's not good. But we try to sort of bring these two things together in a way that makes sense. And so I think, I'm still a computer scientist. I know the most about programming and building systems. And I think the ability to abstract concepts is the most helpful in that sort of translation, where you can take a concept and think about it in a hierarchical breakdown, just like you do with any sort of programming request or challenge, and also to get other people to think about their work in terms of a hierarchical breakdown so that you can implement it on a computer. So I guess we're everything all mixed together all the time, and then depending on what the task is, what we're doing, it's like more computer science or more social science.
Okay. Yeah, so that's a lot. That's really confusing, but it's really interesting. Like, I kind of want to go into that now after hearing that.
It's really cool. You could, I mean, the easiest way is to like look at our project pages, and like you can link it, I don't know, in the YouTube description or something, of like, oh, well, this is our project page. And we kind of go into a little more detail about it, but it's computer science used in a very social sciencey way, which is really cool because you get to and then so much more mess gets put in when you say, I want to implement this with real human beings that are part of a population that could be helped, because it's so noisy and terrible. And there's if you're going to put something in a house with a child with an autism spectrum disorder, then the robot has to be able to have juice spilled on it and be okay, or so it's not. And there's those kind of concerns where we have a physically embodied system. And we have to be aware of that part of it as well.
Yeah. Well, okay, I got one last question. Since you are like going into AI, do you have any like future predictions about like what could happen, or like any accomplishments that you like can foresee happening?
I think that for what we're contributing as a lab, I think, and my thesis work, I think that we're going to see more and more robots going forward. Not just a Roomba, but we have robots like Baxter from Rethink Robotics and Jibo, and Maybu from Catalia Health. And I think that a lot of these are going to tap into the trend in technology of personalization. So not that there's one like Apple Watch that is the thing that everyone wants, but more that technology can be presented to you in a phone or a watch or another thing or a Google Glass, and you have the choice, but depending on what works for you and your lifestyle. And I think that that's kind of what we're tapping into, and I think that's what technology is. That's going to be the next big thing in it, is not just everyone having the same device, but each person having a customized solution for them, something that will learn and adapt to their preferences in a meaningful way, not just like what color do you like, and something that'll help build a profile over time, especially with respect to healthcare. Something that will keep your health records for you and help you interpret that and adjust to you without you ideally needing to really do that much different.
Okay, thank you so much. Thank you for taking your time for the interview, and I'm really glad to hear all of your answers. They're really interesting.
Thank you. All right, well, let me know when it's up. I think I'm excited to see the other people that y'all get to interview, and that'll be fun. So let me know how it goes.
All right, thank you.
All right, thanks. Bye-bye.
Bye.